decarbonization and energy transition. We've done this before. For those joining us for the first time, how this works, you have various startups presenting for 4 minutes, and then they will leave the stage, another startup will come, and then we have several of those. I need you to keep an eye on the startups that you really, really liked, as you're able to vote on 5 of the startups that we've seen all day, and one of them will be the winner of the first PEIC Award Trophy. So the very first presentation that we're going to kick things off, and for those, by the way, who are standing, this is your opportunity to grab a seat, si te quieres sentar. There are chairs at the back. There is one right here, so feel free to come in, grab a seat. We got a couple of seconds rather, while I introduce our very first pitch by Vahid Walker from Walker Subsea, founder of Walker Subsea Engineering, merging next-gen automotive technologies with Subsea systems. You guys are too clever. All these words feel so big in my mouth, always. With Subsea systems to unlock cleaner, smarter underwater solutions. Vahid, the stage is yours. Thank you, and the clicker is there.
Thank you very much. Great intro, much appreciated. So I'm Vahid Walker. How do I move on to the next slide? How do I go back? I'm an engineer and founder of Walker Subsea Engineering, and since 2006, I've been making underwater machines. In that time, we've seen a huge shift in clean power systems led by the automotive industry. And vehicle owners of all kinds, you and I, we share the same concerns, which is, how far can we go on one charge, or without refueling? How fast can we go, and how much can we carry? 20 years ago, there wasn't much adoption of EVs. That's changed. So underwater robots, they're primarily used for 2 purposes, for underwater construction and for defense. What if we gave these machines the same range and the same speed as our passenger cars today? The construction ROVs would build faster, longer, in harsher conditions. We'd be constructing the future energy sites of tomorrow for less. And for defense, considering today's challenges, with 1.5 million kilometers of underwater cable, we'd be patrolling more and giving you more detailed information and protecting our infrastructure. And that's where we come in. We provide underwater power systems to do just that. The opportunity we're seeking is quite straightforward for ROVs. With 24,300 ROVs in service today, we'll be offering them backup power. The ships of today powering the ROVs cost $200,000 per day to run, so even 1 day of downtime would be costly. For defense, we'll be working with the defense primes in order to package our underwater motor and battery into their vehicles. Now, smart underwater logistics. You're thinking this guy's crazy. Underwater logistics. Moving goods around under the sea, why? So, to put that into context, what we've got is 90% of the global goods go through our maritime ports. Yet 60% of our freight emissions don't come from there. Where do you think they come from? The cars, right? From trucks. So we've got a massive final mile problem. And I believe that coastal transport can be part of the solution. I believe that submersible vehicles in particular can be part of the solution to the final mile problem. Now, final mile, that's delivering goods to people's houses or to small communities. We're not going to do that with container carriers, with huge ships, are we? They're just too big. This is definitely a truck-sized problem, okay? So if we have a truck-sized submersible, why would we do that, and what would we get in return? Well, for one, we'd be transiting safely below the waves, whatever the weather. We benefit from stable temperatures. We wouldn't be cooling our cargo. And because it's truck-sized, our ports don't need to be massive. In fact, we'd be connecting remote coastal communities and islands where bridges and airport runways were required in the past. Okay, you might be thinking, yeah, it's still a bit crazy. Fine, I get it. No drama. I'm about as confident on this as 10 years ago people were confident about using drones to deliver goods. It's happening. And for ports, this is happening too. So we are based in Newcastle near the port of Tyne, and they are already have their own 5G network. They use robots to do the stock take in their warehouses. They automate their cranes and have fly-by-wire cargo terminal trucks to move around the containers. And now they're waiting delivery of their own fully electric hydrofoil workboat. So not a lot of work to be done before they accept uncrewed vessels too, and they're not the only port. I've skipped a slide. That's because it was in the wrong order. So what technology do we need to get us there? Underwater motors. Traditionally, we design them to keep the seawater out. Guess what? It's going to get out. Okay? It's going to get in, it's going to flood, it's going to leak, it's going to break down. Our underwater motors are designed to be filled with seawater. No leakage, no problem. An underwater battery pack designed to be maintainable and scalable, providing power directly to the vehicle at depth. We're doing a funding round because we need to bring this to market. In return for our funding round, our seed funding round, we will have a ready-for-market products, and we'd have a facility for production in batches, ready for our Series A funding, and I'm around today and tomorrow, happy to talk to anyone. Thank you.
Thank you, Vahid. I appreciate it. Okay, amazing. We will be moving on to our very next speech from Iñigo Doria, CEO of Arrecife Energy Systems. Iñigo, welcome. Who is developing disruptive wave energy solutions to harness the ocean as a clean power source. Iñigo, the stage is yours.
Thank you. Okay, so yes, we are a small startup, mainly of engineers that are trying to harness the wave energy. We started in 2016 and with the idea of generating electricity from the ocean, but we are seeing that there is a huge problem in ports as there is a need of finding new solutions to generate electricity in the ports. There is a lack of solutions, and there is a lack of space. So we are trying to give a simple and easy solution for them, creating systems with turbines connected to generators. Maybe it's similar to an offshore mill, a windmill that everybody knows, and more or less is the same, but with cross-flow turbines. So it's easy to generate electricity with a direct turbine. It's easy to maintain. There are few moving parts, and we can design all the turbines to work in different ocean conditions. So we have been working since 2016, moving from simulations to different units in the ocean, trials with small units of 1 kilowatt to 50 kilowatt unit. Here you can see some of them, some of the tests that we have done during these years. And of course, we have been learning a lot about all the elements, materials, etc. So right now we have two ongoing projects, one in the port of Mutriku. It's a OWC unit that works with air, but from the waves. It's going to be installed during the next year. And with one, just to have a big number, in 50 meters of dock, we can put 10 units of this system. And at the same time, we are working with the Port of Spain to install another one in the Port of Bilbao. So what we are looking for right now is partners that they want to do pilots, and also investors to keep going with the hardware work. We need to manufacture, we need to test. This take time, but we are doing pretty well. And we believe that there is a huge opportunity for us here. If you have any question, I will be happy to answer it. Thank you.